section 2.2, the other day we started talking about the idea of you can have equations with either 0, 1, 2, or a whole bunch of variables. Up to this point, you've often been limited to 1 or maybe 2 variables. You've seen things like the following. Oh, I don't know. Let's say we have 3 times x minus 4 is equal to 2x minus 1. Is that pretty much a no-brainer to solve? Okay. Real straightforward. Yes, no. Uh-oh, what are you going to do first? I'm seeing some people, yeah, get it out of my face. Other people saying, ooh, get it out of my face. What are you going to do first? Distribute. So we're going to have the 3x minus 12 equals to 2x minus 1. Now what? Subtract 2x, which is going to give us x. And you can also, in the same swoop, do what? Add 12. So that's going to give you 11, and ta-da, it's done. And you're out of here, right? What is it that allows you to add and subtract things from each side? Ooh. Well, I've always been allowed to do it. Nobody said I couldn't do it. If we have something like 2x plus 6 equals 19, everybody knows you can subtract 6 from each side, can't you? Says who? Or says what? Or why? This is actually what's called the additive property of equality. Both sides are being treated the same. In each case, they have something added to them. Chuck, I think you need new glasses. You subtracted. What we did was we actually added what kind of a number? Oh, that's right. We added a negative number to each side. So that's why we can get away calling that the additive property of equality, or I guess you could call it the subtraction property of equality if you really wanted to do that. But there's one for addition, which will give us then the 2x equals 13. What's the next move here? It's to divide by 2 or multiply by a half, whichever way you want to call it. And that's going to give you x equals to 13 halves. Guess what that's called? The multiplicative property of equality. You've been used to doing this stuff for years. Okay. So this is nothing new to you. The things that allow you to do this are the additive property of equality, and the multiplicative property of equality. Okay, those sound familiar? Maybe you've heard them before, maybe you've not. And if you've not, that's fine. That's no big deal. All right. There's a variety of things that can happen when you go to solve an equation. You're accustomed to solutions like what's here on the left-hand side, where you get x equals 11. This is what is termed a conditional equation. With a conditional equation, you have a scenario where the equation is true under the condition that x equals 11. It's only true if x equals 11. If x equals some other value, the equation 2 lines up, this is not true if x is not 11, is it? It's only true under one condition. There are 3 different types of equations. First type of equation, conditional equations. Okay. Let's say we have something like this. 2x plus 7 equals 2 times x plus 3 plus 1. start to work this out, what happens very quickly? What happens to the 2x on each side? They equal each other. So if we use the additive property of equality, we can add a negative 2x to each side, and what's going to happen to the 2x's? 0. They cancel out. Well, that's kind of weird. And I get 7 equals 7. Huh. Well, is that true? It's true. We can work it down even further and get 0 equals 0. Does that make sense to everybody? It's entirely possible to come up with equations that behave like this. These are what are called identities. Okay, with an identity, as you simplify both sides of the equation, you're going to wind up with the same thing on both sides. And if you keep going on the simplification, you'll work it all the way down to 0 equals 0, which is true. No big surprise to anybody. Okay? This is what is called an identity. Identity means the left and the right are the same thing. Okay, so we've got 3 different types of equations going. One is a conditional equation. The second is an identity. And the third one is what's called a contradiction. What's it mean to contradict yourself? Say 2 different things. Politicians are always doing that, right? Yes, I was there during that battle. Well, I was in the country during that battle. Well, I was, and you see them changing their line all the time, right? Okay? You get the idea. You wind up with things that don't line up. Let's see here. Let's say we have something like 3x plus 7 equals 3 times x minus 4. Fairly straightforward one. I think you can see in a real quick order that we're going to have our 3x plus 7 equals, and on the right side when we distribute, we're going to have our 3x minus 12. Using the additive property of equality, the 3x's go away, don't they? You add a negative 3x to each side, and lo and behold, you get this amazing statement. 7 is the same as negative 12. Really? Interesting. I'm seeing lots of people shaking their heads. Yeah, that's not the way it works, Jeff. Okay? Usually if you reach a contradiction, okay, contradiction is kind of a long word. Mathematicians don't like long words. The way mathematicians say it's contradiction is like that. Lots of x's all thrown in there. You see it? One giant x, and then on the tail of the one x is another x, and on the tail of the other part of the x is another x. That means there's a contradiction. Okay? You've run across something strange. This can't be true. Don't leave something like that. If you, not if, let's say when you arrive at problems like this, what are you going to put down as a final solution? There is a blank line there where it says solution. What are you going to put down? Are you really going to leave it as this? That'd be kind of embarrassing, wouldn't it? Because everybody knows that's not true. Is a contradiction. So you can put down, this is the result, but I know that result is not right. It can't be right. I've rechecked everything, and it doesn't work. And that's entirely legit. There are times where it doesn't work. And if it doesn't work, it's okay to say, it doesn't work. Okay? That's better than handing somebody a parachute and they say, is this okay? If it doesn't work, tell them, no, this thing doesn't work, right? You don't want them to jump out of the plane and find out then, oh, crud, it doesn't work. How inconvenient. I'm kidding. In addition to solving things symbolically, what we've been doing up here is moving symbols around. You can solve things symbolically. Another standard way to solve things is graphically. There are lots of equations and situations where it is far less painful to solve it graphically than it is to solve it symbolically. Really? Like what, Chuck? Well, let's say we have something like e to the 3x minus 1 is equal to the natural log of x plus 2. Anybody going to step up and solve that puppy? Chuck, I don't even know where to begin to solve that one. There is a second route for solving these. Okay? And I'm going to cheat and use the graphing calculator because it's the fastest way to get the graphs. But what you can do is, on these, if you have one, great. If you don't, you can watch. Maybe slide over to somebody around you who does have one and say, hey. Okay. So let's see what happens here. We have this graphing calculator. And it's, there we go. Finally going to zoom in. Okay, let's see if we can get this to work. There we are. First thing I'm going to do is I'm going to press y equals. And on the y1, I'm going to put e raised to the 3x minus 1. And close the parentheses. So there's one of the equations. Then I'm going to press enter. And for the other equation, go do the natural log of x plus 2. Close that. Now, at this point, any idea what these graphs look like? No idea. I don't have an idea either. So what I'm going to do is, the next thing, if you'll recall, if you've worked with these before, is you set the window. In other words, what width do you want the window to have, and how tall and how far down do you want it to go? I'm going to press zoom, and I'm just going to do standard, which is option 6. Invalid dimensions, okay. So we're going to come up here. Mine's messed up because somebody else was using it. Here, let's try that. Aha. If you take a look at that graph, do you see that the two lines do hit each other? Now, it's kind of hard to see exactly what's going on, isn't it? Because they're really close to the origin, and there's a whole lot of empty space there. So what I want to do is I want the calculator to look at a smaller area. I'm going to change the window to something like -2 to 2 for the x, and -2 to 2 for the y. Does that make sense to everybody? Assuming that if you have one, you know how to kind of work it. I'm going to press graph again. We've got a closer view of what's going on. Ah, look at there. Can you see where the two intersect? Now, one of the cool things with this calculator is you can then ask it to calculate the intersection point. Above trace, don't use trace. Trace lets you think you have an answer because it gives all kinds of digits, but it's garbage. I mean, personally, if it would have been me, on every single calculator, I would scratch out the word trace so people wouldn't even know it's there. Above it, though, is calculate in blue. How do you get to that? You press the blue button, the second button, and calculate. And wow, there are a lot of different decisions to make here. Are we looking for a value, a 0? Oh, we're looking for an intersection where two lines intersect. And here's where you have to be careful on reading. First curve. Okay, on this calculator in the upper left, it displays the equation so you know what it's calling first curve. That little blinking cursor, or a little spider-like thing, needs to be moved right until it's pretty close to where the two lines intersect. about there. A lot of times you can't get it perfectly on the intersection, but close is good. Press enter once you're close. And then now when you press enter, do you see down at the bottom the cue says second curve? And with the second curve now, you get to pick, well, what's kind of close here? Moving left and right. Well, I guess that looks pretty good there. I'll press enter. Then it comes back, do you want to take a guess? In other words, do you want to move the cursor around to see if you can get it closer? I usually just press enter and leave it alone. Then down at the bottom of the screen, what's it got going there? It gives you an X and a Y value where these two lines intersect. If we were to solve this algebraically, with all the fun stuff it would take, we would wind up with an X value of approximately 0.2665. Normally when you use your calculator, how about we just do 3 digits normally, okay? So this would give you then the solution X. If you were to then take that X value and plug it into either the right-hand side or the left-hand side, guess what value would come out? See the 0.818, the Y value? If you take that X value, 0.266 value, and you plug it into either side of the equation, here we go. If you plug it into either side, either here or you plug it in here, the value you'll get back is at 0.818. So does that make sense on what the X value and the Y value coming out represent? Okay, so if it's something really bad, you can use the calculator to graph it and figure things out. What if I don't have one of those calculators, Chuck? Okay, you want to see something really cool? Have you ever heard of Wolfram Alpha? I don't remember if I mentioned it here or not. I always mention it to the calculus classes. Wolfram Alpha, named after a man by the name of Steve Wolfram. Steve Wolfram is one of those kind of bright sorts. You know, you've heard about people that kind of do a little better than most other people. He finished a PhD in particle physics at age 18. Finished his PhD. Yeah, so, you know, let's step it up here a little bit. You're still in your bachelor's degree, okay? He'd already done his bachelor's, his master's, and his PhD by about your age. Yeah, that's kind of, okay. So he goes out and at some point decides, you know what? I'm going to write a really cool piece of software because he saw a need in the scientific communities for something that will work well. And he wrote something called Mathematica, which is a very good piece of software for doing mathematics. So like if you're a physicist or a chemist or whatever and you're trying to do computations, that is the gold standard for doing that stuff. And then he got that up and running, made a bunch of money off of that, and thought, wouldn't it be cool if everybody else could have access to something sort of like this? The problem with Mathematica is if you get a comma, a dot, or a space out of place, the whole thing goes, which is how it is with most of those. So he wrote this thing called Wolfram Alpha, which interprets what you're saying. It doesn't have to be in a particular format. Okay? Let's try something like this. Sam had 4 cookies. He ate 2. How many are left? When was the last time you saw a piece of software you could type something like that into? Let's see what it does. Maybe it'll work for me. Look at that. First, input interpretation. It's saying, okay, do I understand correctly what you're telling me? Always check this to make sure that it really is interpreting it as what you meant it to be. And then the results, they're too one of the things that's neat for this is that oh wow, look down here at the bottom. Do you see what else it even does? It even draws pictures of 4 cookies and eat 2 cookies and you got 2 cookies. Wow. This piece of software is really nice, and Steve's already made his money. This is free. These are various areas that it will work in for you. So one of these days when you move on to differential equation, oh look, plotting and graphing. You'll do plotting and graphing, yes it will. Which is why I'm coming over to this right now. Well, not for that, but okay. I'm going to really mess with surprises. But it has quite a few areas where you get information. Okay, so Chuck, why are you showing us this anyway? Because if you'll recall, we needed to solve where e raised to, and I apologize, I do not have it right now on the screen. What was the equation's value on the left-hand side? 3x minus 1. Thank you. Minus 1, parentheses, equals the natural log of, was it x plus 2? X plus 2. Solve for x. Okay? So even if you don't have one of those fancy schmancy calculators where you can graph it and see where the 2 lines intersect, you all have access to the internet, right? Okay. Put it in, and the first thing you always do is when it comes back with an answer, which it might do here eventually, depends who else is using it at the time, always first look at what its interpretation of your problem is. Make sure that what it's saying here matches the problem you are working with. If it doesn't, that just means you probably have a parentheses out of place or something like that. And then, oh wow, look, how many answers did we get here? 2 of them, right? What actually happens on that graph is it does intersect in 2 locations. Okay, when we graph this, well, that's kind of ugly. When you graph this, it does something like this. It does something like this. I did not expand the graph enough to really be able to appreciate the fact that there is an intersection point over there as well. But with the Wolfram Alpha, as you can see, it pulls up both of them for you. Does that make sense? So there is a free piece of software that's available online, day, night, whatever. If you go to it, where does it say? Okay, they don't have it on this. They change this around from time to time on what they show and don't show and things. Student pricing, stuff like that. You can buy a subscription to Wolfram Alpha. Well, why would I buy a subscription? It looks like it's working just fine. If you buy a subscription, it's like $3 or $4 a month. And not only will it provide solutions, but there will be a button over here that you can click that says show step-by-step solution. And it'll show you step-by-step how to solve this stuff, how to solve chemistry problems, how to solve differential equations, how to solve calculus, all kinds of stuff for like $3 or $4 a month. I don't own stock in it. I'm not trying to sell. I'm just saying it's there. It's a tool. Okay. But it's actually pretty neat that you can just type in words and it doesn't have to be in a specific format, and away you go. Man, Myron was planning on doing this too, weren't you? And crud. You're almost done with your PhD. Okay, does this make sense how to use this and that this does exist? This is one of the reasons why I say no to telephones and stuff like that on tests and things, because All you got to do is type every problem in there and boom, Steve will do it for you for free. All right. So, one way to solve problems is symbolically. That's what you've been using, moving around letters, numbers. Second way to solve it is graphically, looking for the points of intersection. You have several different ways of which you can do that. One of them is on a calculator, the other's online. When I'm taking Daniel to hockey practices, okay, and I'm sitting there for hours, and I need to get work done, I've actually pulled Wolfram Alpha up on my smartphone, and it runs just fine on there. So you can use it on your smartphone, which is why you're not allowed to use smartphones on tests either, because then Steve can do it for you. But it's there for you to use otherwise, okay? All right. Roots of equations. We've talked about the idea of solving one equation at a time. We've talked about the idea that, gosh, you can get two equations equal to one another. So you have this equation equal to this equation. A very important item to be able to go after is roots of equations. Anybody recall what roots are? Well, they hold up trees. Roots, that's my family. Okay? My roots go back to Germany. Hence the blonde hair, the blue eyes. Good math. Okay. Kind of scary. Like, my son plays second in his entire school on his. He's a sophomore in high school, and they give him these tests. They give him practice tests, like practice ACT tests and stuff. In his math, he placed at the level of a junior. Not a junior in high school, a junior in college. I said, okay. Obviously, if you don't make it in the NHL, you'll have a job somewhere. Anyway, roots are locations where the function intersects the x-axis. Okay. And my daughter's comment was, so what? Or she's down in the engineering college also. And I feel sorry for my wife. She thinks way different than the rest of us. She actually has a heart, and the rest of us are just computers. Okay, anyway, roots of equations. A root is a situation on a graph where the function intersects the x-axis. Now be careful. This does not mean x equals 0. People are quick on the draw to say, aha, x equals 0. Think about it for a minute. If we are over here, is x 0? If you're over here, is the x value 0? It can't be, can it? Because x equals 0 means you'd be on the y-axis. What's really 0 at this point? It's not x that's 0, it's the y value that's 0. So when you're talking about the roots of an equation, okay, roots of an equation means y equals 0. Y equals 0 means where does it intersect the x-axis? These are real important values. Because oftentimes you'll start out with something like 3x squared plus 7x minus 8, and this will be a cost, a profit, some amount of material that you need. Maybe we need 8 tons of whatever this is. Well, let's say 5 tons, and it has to equal 5. Just making something up here. This can be switched around fairly quickly, and you all know how to do this. It can be rewritten as 3x squared plus 7x minus 13 equals 0 using the additive property of equality, can it? Now that it's equal to 0, everybody says, aha, that's easy to solve. It is. But when you say it's equal to 0, that also means you're shopping for what as far as the graph goes? If it equals 0, you're shopping for locations where the graph intersects the x-axis. Does that make sense? Why is it that people always encourage you to get your equations equal to 0? Well, sometimes, not always, this one won't factor, but if you have something that factors like x plus 7 times x minus 4 and the right hand side is 0, you're as good as done getting an answer. Because if it equals 0, one of those two terms there, factors actually, one of those two factors has to equal 0. Either the x plus 7 equals 0, or x minus 4 equals 0. Does that make sense? Well, why does it have to be one of those? How do we know that one of them has to be 0? I don't know. Teachers always just said it was, and I just said, okay, and moved on. Must be something really complicated because nobody's ever told me. You ready for some really heavy-duty math? Nobody ever told me either. It's just one day I was thinking about that. Holy mackerel, this is stupid. Why didn't anybody tell me this? Got an idea, Myron? It's not that hard. Don't overthink it. You've got this thing times this thing equal to 0, don't you? And if you have one thing times another and it equals 0, what has to be true? I'm thinking of two numbers. They multiply to equal 0. What does one of the numbers have to be? 0. There you go. You already knew it. Way to go. Every one of you knew it. If we get this equal to 0, over here, one of these has to be what? 0. It's just that easy. And then that's how you go from these two things multiply to 0 to, well, gosh, this might be 0 or this might be 0. You got to be kidding. That's all there is to it. I was in a calculus class somewhere when it finally hit me, and I wish somebody would have told me this about 5 years ago. That's why they want this stuff equal to 0? Yeah, makes it real easy to solve. No way, get out of here. That's all there is to it. That's all there is to it. It just seems too easy, Chuck. I know. We won't tell anybody though, right? That'll be our secret. Okay. That's why you get it equal to 0. That's a reason why roots are so valued. Does that make sense to everybody? Okay, so we've cruised through a lot of stuff here. We got the additive and multiplicative properties of equality. You've already known those things. Add the same to both sides, multiply by the same. No big surprise there. You learned, we went over how to solve these things symbolically, shuffling around letters and numbers. Went over how do you solve it graphically, either on a calculator or on Wolfram Alpha, or you can even, here's one, you can even draw them by hand and see where they intersect. Okay. Then we went over this thing about why are roots of equations so important. Everybody good? Okay. We'll do the quiz and call it quits for the day. Okay. I will see if I can get some homework up for section 2.2 because this is actually a good chunk of 2.2 all done. Whoa, how about that? Okay. And other than that, not supposed to rain much, so have a great weekend. So we'll get this quiz going.